The decimal system, the foundation of modern mathematics, originated in ancient India. Today, we use it every time we count, measure, or calculate, but few realize that this numerical framework was first developed thousands of years ago on the Indian subcontinent. The system of 10 digits, 0 to 9, place value, and the concept of zero revolutionized mathematics and science across the globe. Before structured mathematics, early humans counted using fingers, pebbles, or tally marks. Over time, ancient civilizations developed symbolic systems for numbers. In India, evidence of counting and mathematics dates back to the Indus Valley Civilization, 3300 BCE, 1300 BCE. Archaeologists have discovered weights and measures with standardized units, advanced urban planning requiring knowledge of geometry and numbers, symbols on seals, possibly representing early forms of numeric records. Although these symbols are undeciphered, they mark the beginning of India's deep relationship with numbers. The Vedic period, 1500 BCE, 500 BCE, laid the foundation of the decimal system. Ancient Indian scholars developed a base 10 counting structure, meaning numbers were organized in sets of tens, a concept still used globally today. Key texts such as the Rigveda and Yajurveda show early examples of decimal organization. Numbers were grouped systematically as EKA, 1, Dasha, 10, Shata, 100, Sahasra, 1000, and so on. This hierarchical organization made calculation easier and laid the groundwork for the decimal place value system. Perhaps India's greatest mathematical gift to humanity was the invention of zero. Before zero, ancient Egyptians, Greeks, and Romans had number systems, but none had a true symbol for nothingness. This made calculations cumbersome and limited. The concept of nothingness first appears in the Rig Veda, approximately 1500 BCE, where the term sunya, void, is used. In the Bakhshali manuscript, 3rd-4th century CE, discovered in Pakistan, we find a dot symbol representing zero, the earliest recorded evidence of zero in writing. The real revolution came in 628 CE when Brahmagupta, an Indian mathematician, formally defined zero in his seminal work, the Brahmasphutta Siddhanta. He introduced zero as a number, not just a placeholder, established rules for arithmetic involving zero, such as dividing by zero, though misunderstood then, was also explored. This concept of zero transformed mathematics from a counting tool into an abstract system of logic. Equally significant was India's positional decimal system, where the position of a digit determines its value. For example, in the number 432, the 4 stands for 400, the 3 for 30, and the 2 for 2. Before India's innovation, most ancient civilizations used additive systems, like Roman numerals, XL2 equals sign 42, which made large calculations extremely complex. By combining place value with zero, Indian mathematicians created a compact, efficient, and scalable way to represent numbers, essential for modern science, finance, and engineering. India's decimal system didn't remain confined to the subcontinent. It traveled the world through trade, conquest, and scholarship. Transmission to the Islamic world. By the 8th century, Indian mathematical texts were translated into Arabic. The system became known as the Hindu numeral system in the Arab world. Through Islamic Spain and the works of Leonardo Fibonacci, author of Liber Abaci 1202 CE, the decimal system reached Europe. Initially resisted in favor of Roman numerals, it eventually became standard due to its efficiency. By the 15th century, Indian numerals and the decimal system had become universal. The invention of the decimal system, and zero in particular, sparked a global mathematical revolution, advancing astronomy. Indian astronomers like Aryabhata and Brahmagupta used the decimal system to calculate planetary movements, eclipses, and solar cycles with remarkable precision, boosting commerce and accounting. Merchants could now calculate interest, taxes, and profits efficiently, helping India become a hub of trade in the ancient world. Laying the foundation for modern science. Without the decimal system, there would be no calculus, engineering, computer science, or artificial intelligence as we know them today. Why the decimal system was revolutionary. India's contribution stands out because it combined three powerful ideas into one framework. 1. Base 10 counting, simple, logical grouping by tens. 2. Place value, making numbers scalable and efficient. 3. Zero as a number, enabling abstract computation. This trio made mathematics accessible, powerful, and universal, a feat unmatched by other ancient systems. Even today, the numerals 0-9 are called Hindu-Arabic numerals, acknowledging India's foundational role and the Arab world's role in transmitting them. Institutions like UNESCO and historians worldwide recognize India's decimal system as one of humanity's most transformative inventions. Thank you for watching. Hope to see you in the next video.